of chemistry are, one is organic chemistry and second one is inorganic chemistry. Now how to identify the organic chemistry and inorganic chemistry? In case of organic chemistry, generally it contains the compounds which are made up of carbon and hydrogen. Now whenever I say carbon and hydrogen, that means that is a major part. So याचा अर्थ असा आहे का की इनऑर्गॅनिक मध्ये कार्बन नसतोच, असतो. फॉर एक्झाम्पल आय विल शो यू द एक्झाम्पल. CO2 घेतला मी, so it is a carbon dioxide, but does it contain hydrogen? No, so it is not organic compound. So organic compound जेव्हा तुम्ही म्हणता तेव्हा त्यात दोन गोष्टी असायला पाहिजेत, एक कार्बन आणि दुसरा हायड्रोजन, अँड दे शुड बी इन अ मेजर अमाउंट. सो तुम्ही जर बघितलं, सपोज मी जर असं लिहिलं की CH4 आहे, what it is? Definitely carbon and hydrogen is a major part, and therefore this is the organic compound. One more I will give you, C6H12O6. What it is? Again the same thing, we observe the number of times C6H12O6 from 8th, 9th. So this is the actually the structure is again the organic, which gives the energy to everything. Now whenever we say these are the organic and inorganic compounds which are observing, or you are observing from 8th or 9th, just I am concentrating here onwards on the organic compounds. Now whenever I say organic compounds, I already said compounds which contain major part as carbon and hydrogen are called as hydrocarbons, and such compounds are known as organic compounds. So after the organic compound, the thing comes, I come to first basic structures, how they are formed in organic compounds. So before starting with the formulas or electron dot structure, I will just go to the basics of carbon. So first thing I should have to know all the things about the carbon. Carbon is having atomic number 6. As it is having the atomic number 6, therefore its electronic configuration is 2,4. What it indicates? It contains 4 electrons in the outermost shell. Whenever it contains 4 electrons in the outermost shell, we have seen one basic in 10th. What it is? Whenever any element complete its either duplet or octet, it becomes a stable. So to complete the duplet, it should have to lose 4 electrons, and to complete the octet, it should have to take 4 electrons. Both are not possible easily because the atomic number is 6, and for such atom to lose the 4 electrons or to gain the 4 electrons very hard. So what it will do, just I will show. This is the carbon, and if this is the carbon, what it is doing, it is taking in any reaction. Suppose these are the 4 electrons which are present. Let we say it reacts with 4 different atoms like hydrogen. If it reacts with 4 different atoms, what it forms? Just check it. CH, CH, CH. But what the thing is, if you are observing, hydrogen is having atomic number 1. Whenever we say the hydrogen is having atomic number 1, that means it contains only 1 electron in the outermost shell. So to complete its duplet, it requires 1 more electron. So hydrogen is not going to lose 1 electron. At the same time, we have already discussed carbon is not going to give the electron. So what is happening here? Whenever the bond is formed by mutual sharing of the electron. म्हणजे काय? तर कार्बन त्याचा एक इलेक्ट्रॉन शेअर करेल कोणाबरोबर? हायड्रोजन बरोबर, आणि हायड्रोजन त्याचा एक इलेक्ट्रॉन शेअर करेल कार्बन बरोबर. सो आता जर मी बघितलं तर हायड्रोजनचं डुप्लेट कंप्लीट झालंय. सो आय कॅन ऑब्झर्व एव्हरीवेअर हायड्रोजन हॅज completed its duplet. But at the same time, if you observe one more thing, you can clearly observe that the carbon which is present at the center has completed its octet. Thus both carbon as well as hydrogen completed their duplet and octet respectively, and the compound becomes stable. But what the case is, so in such a case, the bond is formed by sharing of the electrons, and such a bond is known as covalent bond. Such a bond which is formed by the mutual sharing of the electrons is known as covalent bond. We know that one more type of bond, that is nothing but ionic bond, but generally the organic, in case of organic compounds, you will never observe that carbon is forming a ionic bond, but it always forms covalent bond. So I am coming to the electron dot structure. Whenever we say the electron dot structure, just we have seen there are the two types of bond. Either it may be the covalent bond or it may be the ionic bond. Now, whenever I say the covalent bond or ionic bond, the first basic thing we should have to know, whenever the bond is formed in any case, it requires two electrons. Suppose I am showing it is a CH. What it indicates? It contains two electrons. One electron is of the carbon and second one is of the hydrogen. And then the bond is formed. But what the electron dot formula is, whenever any structure is represented by the electrons, but that electrons are shown by the dot, then that structure is known as electron dot structure, or that formula is known as electron dot formula. For example, we are already familiar with methane. I know that methane is, we generally write it as a CH4, but how it is? This is a carbon, so I am just drawing a dots here. So these are the four dots, that means these are the four electrons of the carbon, but at the same time I am drawing here the hydrogen, that means the electron of hydrogen. So this is a dot. So if there are two dots, that means it is forming one bond. Same thing here, I am drawing dot, and this is the hydrogen. Here I am drawing dot along with hydrogen. So if you observe how many bond does it form, now I can show this is a carbon, one bond, second, third, and fourth. So in this case, carbon is forming four bonds, that means its octet is completing, and here the structure which I have drawn is representing the electron dot formula, whereas here whenever I am showing the bond, that is known as dash structure, or you can say electron dash formula. So first one is electron dot formula and second one is electron dash formula. So here we can observe that after the electron dot structure, there is a one more structure or one more type of formula, that is the bond line formula, in which I have already shown you that whenever the structure is drawn, I can say that the central one is a carbon along with four bonds. So each bond is showing two electrons, or bond is representing the two electrons. Now after that we are moving to the next point for the condensed formula. Here the number of students get confused. So I think you are already familiar with the alkanes, that is nothing but methane, that is the first one is methane, which is represented as a CH4, which we have just written. Thereafter we say ethane, but ethane again in case of alkane we know that the general formula is CN H2N plus 2. So it is the C2H6, but this is not a condensed formula. So what the condensed formula is, suppose I am writing it like this, CH3CH3. Now most of the students will ask, why sir you are writing like this? Because I am completing all the four bonds of carbon. So just see, this is a carbon, 1, 2, 3, and this is the fourth one. Same thing, I'm drawing one more. This is a carbon, already one bond is there. This is a second, third, and fourth. But what this is the bond line formula. If I replace the dash by dot, then that will become electron dot formula. And here, whenever I combine all this, what it forms is CH3CH3. So this is nothing but condensed formula. Again, I will just go for beyond this. If I want to go for the next compound, I will write CH3, CH2, CH3. And again, if you combine all this, this becomes C3H8, that is nothing but a propane. Whenever I am saying this is nothing but a propane, this is also condensed formula because I am writing it combinedly. But the thing is that this is, you cannot say this is the condensed formula or this is the condensed formula. Why? Because I already said, whenever you are writing the condensed formula, never show these bonds in between it. So how I will write? I will say it is a CH3, CH2, CH3. But instead of that, I am going one more beyond this, C4H10. And now concentrate friends, it is a CH3, CH2. So I can say it is a CH2, CH2, CH3. But if you observe carefully, the term or the in the middle CH2 repeats twice. CH3 is not repeating. One is at the start and one is at the end. So instead of writing this, I can write it in a one more way. How I can write it? I can write it as CH3, CH2 twice, because the CH2 group comes twice, and this is CH3. So in this case, both the formulas are condensed formulas. I can use this as well as this. Okay, so these are the basic parameters how you should have to write the condensed formula. So the in case whenever we are showing the condensed formula, you can observe here how many number of carbon atoms are here. There are 6 carbon atoms. But what the thing is, basically the thing is that the first carbon atom is containing 3 hydrogen atoms, and last one is also containing 3 hydrogen atoms. So structure can be represented as CH3, but in between that there are 4 CH2 groups. So I can say it is a CH2, CH2, CH2 as I have shown here. But instead of that, if I want to show them combinedly, that means it is condensedly. If I want to show them, how I can show it? I will say it is a CH2. How many times? 4 times. And lastly, what? Again, it contains CH3. So this is the fact. I can write it like this. That is CH3, CH2 4 times and CH3. पण जर समजा एखाद्या ठिकाणी मध्येच कुठेतरी CH3 असतं, मध्येच कुठेतरी जर मित्रांनो इथं CH3 असतं, तर काय झालं असतं? हा CH3 जो आहे हा कोणाला कनेक्ट आहे? सेकंड कार्बनला कनेक्ट आहे. मग काय होईल? आता मी CH24 लिहू शकत नाही, पण मला माहिती आहे की पहिला स्ट्रक्चर काय आहे? CH3 आहे. मग त्याच्यानंतर दुसरा कार्बनला एकच हायड्रोजन आहे. सो आय विल राईट ओनली दिस मच. पण मध्येच CH3 ग्रुप येतोय, तो मी त्याला काय करेन? मी त्याला उचलून ब्रॅकेट मध्ये टाकेन CH3. परत एकदा मी पुढे बघेन काय आहे पुढे, नीट बघा. हे 3 ग्रुप आहेत की ज्याच्यामध्ये काय आहे? CH2 आहे. सो इट इज अ CH2. बट हाऊ मेनी टाइम्स? इट इज अ CH2 थाईस. आणि शेवटी परत काय आहे? CH3. So I can write the condensed formula in different ways, but this is the method how you can represent this compound using condensed formula. Moving ahead to the wedge formula, the first thing, the carbon is having the 4 bonds. Whenever you are saying the carbon is having the 4 bonds, we are considering that the carbon is on the plain paper. But in case of carbon, we generally have a tetrahedral structure, out of which the 2 bonds are on the paper. So the 2 bonds remain. So we think that one is coming out of the paper. So जो पेपरच्या पुढे येतोय मित्रांनो, त्याला आपण म्हणतो आउट ऑफ द पेपर. 3 डायमेन्शनल स्ट्रक्चर आहे, मग मला काढायला जागा नाही म्हणून मी काय दाखवेन? आय विल शो इट विथ द डार्क लाईन्स. सो हा जो बॉन्ड आहे तिसरा, हा पेपर मधून बाहेर येतोय. आणि जो चौथा बॉन्ड आहे मित्रांनो, असं आपण अज्युम करतो की दॅट बॉन्ड इज गोइंग below the paper, so that is represented which is moving away from the paper on the back side. So in this case, whenever I am saying everything is possible, what is the parameter? That we are only thinking that the 4 bonds, out of which 2 are on the paper, one is below the paper and one is above the paper. Okay, in case of Fischer projection formula, some things are very important. A Fischer projection formula can be drawn by visualizing the molecule with its main carbon chain vertical. तुम्ही जर इथे बघितलं तर मेन कार्बन चेन वर्टिकल आहे, सेंटरला कार्बन आहे असं कन्सिडर करायचं आहे, वरती COH आणि खाली CH3, दॅट मीन्स दॅट इज द मेन चेन. सेकंड थिंग, कायम सेंट्रल कार्बन हा क्रॉसनी रिप्रेझेंट करतात. सो सेंटरला कार्बन आहे, जरी तुम्हाला दिसत नसला तरी लक्षात ठेवायचं सेंटरला त्याच्या कार्बन आहे जिथे क्रॉस झालाय. सो व्हेनेवर आय ड्रॉ दिस स्ट्रक्चर, इट रिप्रेझेंट्स की या सेंटरला कार्बन आहे. आणखी एक महत्वाची गोष्ट, जेव्हा तुम्ही ड्रॉ करताय तेव्हा कन्व्हेन्शन इज दॅट होरिझॉन्टल लाईन रिप्रेझेंट्स दॅट the 2 bonds are coming out of the paper. म्हणजे मी म्हणून त्याला वेज मध्ये कन्वर्ट करून बाजूला काढलाय मित्रांनो. तुम्ही जर हा हायड्रोजन आणि OH बघितला तर तो मी मुद्दाम वेज मध्ये हा डार्क करून दाखवताय. व्हॉट इट इंडिकेट्स की हे 2 बॉन्ड्स पेपरच्या वरती येत आहेत. सो horizontal lines of cross represent that bonds are projecting up from the carbon, whereas vertical lines represent that bonds are going below the carbon. म्हणून मी इथे डॉटेड काढलंय तुम्ही जर बघितलं तर. सो इफ युअर these 2 concepts are clear, you can convert the Fischer projection into the wedge formula, or you can convert the wedge formula into the Fischer projection. बोला, कोणाला काय डाऊट?
सर
नक्की आता नोट करून घ्या, नोट करा, नुसते नो म्हणू नका, नोट करून ठेवा, कारण काही दिवसांनी मी तुम्हाला 5 साईजचे फॉर्म्युले विचारले प्रोजेक्शन, तुम्ही म्हणणार काय सांगितलं नाही काय नाही.
सर केलं.
ओके, आता याच्यावर अजून एक लगेच सांगून टाकणार मग तुम्हाला.
सर 1 मिनिट.
येस, आर्यन रिपीट करतो, ठीक आहे. आर्यन, तू गाडी बघितलीस, मी ह्या चाकाच्या पुढे उभा राहिलो आणि इकडे बघायला सुरुवात केलं, पलीकडचं चाक दिसतं का रे, मधला ऍक्सल दिसतो का, इकडे पण एक चाक आहे तुला काढायचं म्हणून, तुझ्यासाठी म्हणून मी काढतो ते मागचं चाक. असं समज की ट्रान्सपरंट चाक आहे, ट्रान्सपरंट मग दिसेल. हा, पण मी जर इथे उभा राहिलो तर मला फक्त फ्रंटचं व्हील दिसेल, बॅक व्हील दिसेल का, नाही दिसत. म्हणजे पलीकडचं चाक दिसेल का, नाही दिसणार, फ्रंटचं दिसतंय. पण न्यूमॅननी काय सांगितलं, ते दिसतंय तसं काढू नका, फ्रंटचं जे व्हील दिसतंय त्याचा फक्त सेंटर काढा, आणि जो बॅकचा आहे त्याचा सर्कम्फरन्स काढा. आणि फ्रंट व्हील पासून किती तुम्हाला दाखवायचे, तर एक बॉन्ड मागे गेलाय कार्बनचा, हे लक्षात घ्या, लोक हे विसरतात सराईतपणे. फ्रंट कार्बन पासून बॅक पर्यंत एक बॉन्ड गेलाय, म्हणून हा मध्ये तो दिसणारच नाही मला, मी पुढे उभा राहिलोय म्हणून मला मधला बॉन्ड दिसत नाही, तो चौथा आहे. राहिले किती बॉन्ड, 3. मग 3 बॉन्ड कसे दाखवले मी, हे 3 बॉन्ड मी दाखवले 3 हायड्रोजननी, जे फ्रंट कार्बनचे सर्कलच्या सेंटर पासून जात आहेत. मग मागच्या कार्बनचं काय, तर मागच्या कार्बनचे बॉन्ड हे त्याच्या सर्कम्फरन्स पासून बाहेर दाखवायचे. म्हणून जर तू नीट बघशील राजा, तर फ्रंट कार्बनला मी इथून दाखवले 3 बॉन्ड, 1 2 3, आणि बॅकला जे दाखवले ते मी एक सर्कल काढला आणि त्याच्या सर्कम्फरन्स पासून दाखवलं. सो व्हॉट इट इंडिकेट्स, की पुढच्या कार्बनचे 3 बॉन्ड आहेत आणि मागच्या कार्बनचे 3 बॉन्ड आहेत.